Assalamu alaikum and good morning. This is Ansari Yasmin, and today I have come up with a new video, new topic from Standard 10th. I'm not going to reveal the name of the topic. I'll ask you some questions, I'll show you some videos, and then we'll come to the topic. Students, you all must have observed a light entering into your room through a small opening of your window, and you must have observed that it travels or it enters into a straight line. We all know that light travels in a straight line. It follows rectilinear propagation. But what if I'll ask you to bend the light? What will you do? We all know that when I'm talking about a beam of light contains many rays. But each ray travels in a straight line. But if I'll ask you to consider one ray of light and I'll ask you to bend this ray of light, what will you do? Will you use your hand to bend it? Of course, no. We need certain material to bend it. And yes, you guessed it right. We can use mirror to bend the ray of light. Light ray, after striking on the mirror, gets bounced back or reflected back. But there is another way to bend or to change the direction of the light ray, and that is a transparent material. Students, air is a transparent material. But if we use another transparent material like glass slab, and if we make the light fall on this glass slab, the light ray, when it will enter into the glass slab, will change its rectilinear propagation, or it will change its direction, and it will get bent. And yes, this is our today's topic. This bending of light due to change in the medium from one transparent medium to another transparent medium is called refraction of light. And we are going to learn this topic, refraction of light. And at the end of this video, I'm sure you all will be able to define what is refraction, and you all will understand the phenomena which involves refraction of light. Students, you all must have heard this rhyme since when you were kindergarten. Twinkle, twinkle, little star. But have you ever wondered, why do these stars twinkle? We are going to answer all these questions. You must have seen the beautiful rainbow in the sky. This is a sunrise or a sunset, but there is a term, early sunrise and delayed sunset. What is the reason behind it? You all must have seen the bottom surface of the swimming pool seems risen up. What is the reason behind it? So, here there is a glass filled with water and a spoon or pencil is kept in the glass. And when we'll observe it from outside, it looks like broken or it looks bent. Is it really bent or broken? Then why does it look like? What is the reason behind it? The answers to all those questions is refraction. But before going into detail, let's understand the basic things about light. Here you can see a Chintu is entering into his room and he is looking scared. He's scared because there is complete darkness, and he is not able to see anything in the room. But as Chintu switch on the light, he is happy now. He can see each and everything clearly. How do we see the object? Students, when the light ray falls on the object, it gets reflected back and enter into our eyes, like here. A source of light falling on the bed, and after striking to the bed, it's reflecting and entering into Chintu's eyes, and Chintu is able to see this bed. This is how we see the object. But what is light? Do we know what is light? What exactly light is? Students, light is a wave, but it's not a simple wave. Light is having that is, it is having electrical field. Magnetic means it is having magnetic field, and it's wave. So if I'll ask you what is light, so you must answer it is an electromagnetic wave. It is a wave which is having electrical field as well as magnetic field. If it is a wave, do you know what are the parts of the wave? Means parts of the light. The topmost part which you can see in the wave is called crest. The lowest most part of the wave is called trough. And if I'll ask you, what does one wave form? So one crest and one trough makes one wave. The distance between two consecutive crest or trough is called wavelength, means length of one wave. So if we need to measure the length of the wave, we need to measure the distance between two consecutive crest, or distance between two consecutive trough, that is wavelength. Students, see this point A. Suppose this is a fixed point, and I'll allow the light wave to pass through this fixed point. When a light ray passed through this fixed point A, the number of waves passing through this fixed point A in 1 second is called its frequency. Frequency is the number of waves passing from a fixed point in 1 second. If suppose 10 waves are passing through this fixed point A in 1 second, I can say the frequency of this light wave is 10 Hertz. Hertz is a unit of frequency. But what if I reduce or if I increase the wavelength? Let's see this video. You can see the point A and the waves are passing through this point A. But if I reduce the length of the wave, the number of waves passing through this point A in 1 second will increase because I have reduced the length of wave. So from this we can conclude that frequency is inversely proportional to wavelength. If wavelength is more, frequency would be less. If wavelength is less, frequency would be more. So to sum up, we can say this: long wavelength light would be having low frequency, and short wavelength light would be having high frequency. When we will talk about colors, the red color light is having a maximum wavelength, so it is having low frequency. So for today, that's it. The questions which we had asked, the phenomena which I had shown in the earlier slides, we will discuss in my next video. Take care. Thank you.